In this video, we're going to be looking at a topic that is really important for the higher level, and it always goes under the radar and is very easy to miss. So, the difference of two squares. If we take a step back a minute and just have a look at something like this, x plus 3, x minus 3, where we have a bracket which is almost exactly the same, but 1 plus and 1 minus. When we do our expansion, x squared minus 3x plus 3x, and then 3 times minus 3 is minus 9. What's special about this type of bracket is that the two middle terms, if we do it in this order, the x terms, will actually cancel out. So the 3x and the minus 3x will disappear and leave you just with x squared, a minus, and then 9, which is 3 squared. So the name gives you the kind of format of this. Difference is take away or subtract. And then the two squares, so we've got x squared and 3 squared. Okay. And when we expand the difference of two square brackets like this, it doesn't really impact us at all. It's just, oh yeah, the middle ones cancel and that's fine. We're much more likely to see a question where we have to go back the other way. And when we see a quadratic like this, x squared and no middle term with the minus and the 9, it's not obvious to see how to factorize this back into the double brackets, because we're used to seeing something like this. And when we factorize, we can look for the factors of 12 and then, what adds to give 7, like this kind of thing. We're kind of used to doing this at this level, okay, the grade 5-ish level. We're kind of used to doing this. But when we see this, it's not so obvious how that factorizes. So the key to the difference of two squares is to always be on the lookout for something squared, then a minus, and then something else squared, like this. And that's what you want to be on the lookout for at the higher levels. And I'll show you where this sort of crops up in a moment. But at the moment, right now, we're just going to be trying to look for this kind of format. So it could be something like a squared minus b squared. And it asks you to factorize this. And this is something that when students first see it, they go, what? The a squared minus the b squared would look something like this. A plus b, a minus b. Okay? It doesn't look like a quadratic, and so it's very difficult to factorize this into its double brackets. Something squared, and then always a minus, and then another thing squared. Okay, now sometimes they make it even harder than this, where they might have something like 50x squared minus 72, like this. And so when we look at factorizing this, it's super difficult because we don't see the quadratic. We've got this 50 there that's causing us problems. So when it says factorize, let's just try to go back a step and say, well, what's in both of these? They're both even. So let's just try to pull out the 2 and see what happens. 25x squared minus 36. Okay. Do you see how that helps? Possibly not, because it still looks nothing like something that we could factorize. But the numbers that they choose will always be from the list of the square numbers that you're meant to be aware of. When you see 25, you're meant to be thinking, that's 5 squared, and 36, that's 6 squared. So the knowledge of the first 12 square numbers will help you to recognize these, because 25, like I said, is 5 squared. So this would be something like 5x, which is the square root of this, plus 6 for the 36, and then 5x minus 6 for the second bracket. So you can see the 25x squared here and the 6 times 6 to give you the 36. Like I say, it's very, very difficult to spot these, but the topics that they appear in are very consistent. So you will often see these difference of two squares in standalone questions, like a squared minus b squared, and it says factorize, and you're looking at it and going, I don't know how to factorize this. Try to think of difference of two squares in that situation. And also in algebraic fractions, you might have something like this, 25 over x squared plus 6x plus 5. And we have to simplify this, okay? So this is a very common use case of difference of two squares, x plus 5, x minus 5, and for the denominator, x plus 1, x plus 5, and then we can cancel our brackets and we're left with x minus 5 over x plus 1. Now that's for a later video, the actual process, but I'm just showing you where this often appears so that you can see it. And it also appears in surds when we have our denominator root 3 plus 1 and we times it by root 3 minus 1, like this. So that gives us this difference of two squares on the denominator, which makes the surds disappear. So if you haven't done surds or you're not too sure about algebraic fractions, don't worry too much. But as you're studying this, what you want to bear in mind is that you want to have this idea of difference of two squares. I have to know what that is and how to factorize it. But also, where are the links in the curriculum where I would often see that? So algebraic fractions and surds. That helps you to start building up those common questions where you want to be on the lookout for this particular strategy.